In this AP Calc question, we're being given an equation to start with. They're telling us that the velocity here, this v function, is given by this equation, v of h equals 3 square root of h, where h is the depth in meters and velocity is in meters per second. Then they ask us what is the rate of change in these crazy units here, meters per second per meter, which you've probably never heard of until you read this problem, of the velocity with respect to the depth of the water when the depth is 3 meters. Oftentimes, I just kind of tell people, go with your gut on something like this. When we're talking rates of change, we're talking about derivatives. And so what my gut is telling me right now is that they want me to find v prime of 3. If I wanted to do a quick check just to make sure, I can check my units, because that's definitely the funkiest part about this meters per second per meter unit. So to check units on a derivative, I always go back to the idea that a derivative is dy dx. So in terms of this problem, our y value was the same as v, so this is dv over, and then our x value would be h. dv over dh. So that means I'm going to have my v units over my h units. So the v units are meters per second. So that would be the units on top. And then the h is in meters. And so as I look at this right now, do these units here match up with the units that I said I'm looking for in my problem? I've got meters per second. Cool, that's the top here. Meters per second per another meter, per meter. Okay, that's my units. They match up, so I was on the right track. I'm really being asked to find v prime of 3. So that means we need to start off by finding our derivative of our original function. So v of h is equal to 3 square root of h. Before we rush in to take the derivative, you always have to be on the lookout for a handful of algebraic rewrites. And what we've got in front of us is the classic radical, the classic root rewrite. Anytime you've got a root in a problem, you always need to rewrite that as an exponent. So if you have x to some power inside a root, you would rewrite that as x to the power divided by the root. So if you had like the cube root of x to the 5th, you'd want to rewrite that as x to the power of 5 over the root of 3. On this problem, we've got an unwritten 1 for our power and an unwritten 2 for the root. So the rewrite on this, v of h would equal, go ahead and rewrite that cleaner, v of h would equal 3, and then this would be h to the power of 1 over the root of 2. So that was a rewrite only. We have not taken any derivatives yet. Now that we're there, now we're ready to go take our derivative. And to do that, we're just going to follow our classic power rule. So the power rule for derivatives says bring the power down. This is my saying at least. Bring the power down. And then step 2 of the process is you're going to go ahead and subtract 1 from the power. So following our power rule on this problem, we would bring the 1/2 down. So v prime of h, 3 times 1/2 would get us 3/2. H, subtract 1 from the power, 1/2 minus 1 would get us -1/2. Then what we're going to want to do now is we needed to go find out what is v prime of 3. Before I go to plug that in though, what I always tell people is negative exponents are great for doing calculus. They are horrible for doing algebra. So as we are getting back into doing our process here, we're going to need to undo that rewrite. So that was another rewrite that you would have normally been on the lookout for. This rewrite comes from whenever you've got a number over x to a power, you rewrite that by bringing the x up from the bottom to the top and making that power negative. So if we had something like 5 over x to the 3rd, we would have rewritten that as 5x to the -3. So what we're in is we're in this situation over here where we have the negative exponent and we want to undo that negative exponent. So we want to move that back down to the bottom. So this would be 3 over 2, and then I would move that down to the bottom and make that h to the 1/2. Now I'm ready to go ahead and start plugging in my value. So again, we're trying to find v prime of 3. So v prime of 3 would equal 3, and then this is 2, and then here we have 3 now to the 1/2 power. Well, you'd kind of stop and look and see if your answer matches any of the answers up above, and it doesn't right now. And why not is because they're actually having us do one more little laws of exponents move. This is 3 to the first on top, and we've got 3 to the 1/2 on bottom. And what you do when you need to rewrite that, when you've got division with your laws of exponents, division is a subtraction game. And when you subtract, you're going to subtract the top exponent minus the bottom exponent. So out of here, we would get top exponent of 1, bottom exponent of 1/2. So 1 minus 1/2 would give us 1/2. So we'd end up with 3 to the 1/2 on top, and then we've still got our little 2 hanging out down at the bottom. Still not exactly what they want for our answer, and that's because we basically now need to undo the rewrite that we did from earlier. We're in this power over root side, and they want us to put the root back into this. So this is 3 to the 1/2. That's a square root. So we would rewrite this as the square root of 3 over 2. And now we can see what we want for our answer. So when we see the term rate of change on a problem, even on a crazy word problem like this, you kind of want to lean heavy towards the fact that this is probably going to be a derivative problem. And then to check on that before you go down that long list, you can oftentimes use those units, even when they're weird, by using your derivative over here, your derivative notation, to sort of notate your units and see if you're on the right path. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.